deriving the quadratic formula. The quadratic formula we've been using, and I never really explained where it came from. You don't need to be able to do this, but I do need to have gone through with you how to rearrange the general form of a quadratic equation, ax squared plus bx plus c equals 0, into terms of x equals, so x is the subject, and when we do that we find that what we get is the quadratic formula, which gives us our two often possible solutions for x. So we're going to have to do some stepping down to get x on its own. And I've got x squared and x, which makes that a little bit tricky, so we're going to be using a few of the skills that we've got so far. I'm going to start by dividing both sides by a, which means each of these terms divided by a, and 0 divided by a is 0. A over a cancels out, so I've got x squared plus b over a x plus c over a equals 0. Now, I'm going to complete the square for this, because I'd like to be able to factorize out, so I don't have this x squared and x. So when I'm completing the square, you'll remember that's b over 2 squared. So b is actually b over a, so that's b over 2a squared. So I've got b squared over 4a squared, remembering to square both of these. So I complete the square. X squared plus b over a x plus b squared on 4a squared, remembering that that's a perfect square and I'll factorize it, minus b squared on 4a squared, because I've got to cancel out that I added it, plus c over a equals 0. Factorize this. Now don't be scared about factorizing, because I know that this term inside the brackets that gets squared is going to end up as our common factor down, as our factor down here. So that's x plus b on 2a all squared, and I've got minus b squared on 4a squared plus c over a equals 0. What I will want to do is get x on its own, so I can get rid of these over to the other side at this point. So I don't want to factorize this as dops, because my aim isn't factorizing, my aim is getting x on its own. So I'm going to get these two over to the other side. So I've got x plus b over 2a all squared equals b squared on 4a squared minus c on a. So I've added b squared on 4a squared to both sides, subtracted c on a from both sides. Now here I've got a pair of fractions that are subtracted, so I'll need a common denominator to gather like terms before, or to gather this up before I go any further. My common denominator is obviously going to be 4a squared, so I'll need to multiply this fraction by 4a on 4a. So I've still got x plus b on 2a squared over here, and I've got b squared. Now the whole thing's going to end up on 4a squared, because I'm multiplying this by 4a to get 4a squared, and so 4a times c, or times negative c, minus 4ac. Now here you're starting to see our quadratic formula emerging, because that's our discriminant popped up here. Keep moving. I want x on its own, so I'm doing reverse order of operations to work back to just x. So the next thing to deal with is the fact that this is all squared. So I'm going to take the square root of both sides. That leaves me with x plus b on 2a here equals the square root of b squared minus 4ac on 4a squared. Now that's the square root of the whole expression. If we wanted, we could put that in brackets to make that very clear. Also at this point, we know when we take a square root, we could get a positive or a negative answer, so we make that very clear by saying plus or minus the square root of this expression. We're getting there. I want x on its own, and that's really easy now. I just have to take away b on 2a from both sides. Minus b over 2a plus or minus. Now also at this time, I've just taken away this b on 2a, but I'm also going to simplify what's happening over here because I've got the square root of a quotient, a fraction, and I can separate it out to do the square root of the top over the square root of the bottom, and the square root of the bottom would get me something nice like 2a, because the square root of 4 is 2, square root of a squared is a, so I'm going to leave the square root just on the top and simplify the square root of 4a squared, which is 2a, and look how close we're getting to the quadratic formula now. That gives me two fractions that are both over 2a, so I can combine them into one. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And that is your quadratic formula. That is why and how I can use the quadratic formula to get the solution or solutions for x, because it's just the rearranged version of the general form of the quadratic equation.